Hi, everybody. Welcome back to my channel, Numbers with Nora. This is a math tutoring channel that helps you with all your math needs, helps you with math homework and understanding math. This specific video is going to be on SAT math. Just a bunch of, I think we're going to finish 10 practice test questions on here that you'll see on the SAT. If you have any questions on these, just drop a comment below. And then also you can follow along. And I'll sit there and post this with my video as well. I got this practice test from collegeboard.org. They have about 5 really good SAT practice tests that you can sit there and practice with. And I'll sit there and do 10 of those problems from there. So let's start. All right, so this is going to be from the math test. This is the no calculator section. It should take you about 20 minutes to do this. They give you about 20 minutes. And it's usually about 20 questions, but I'm just going to do 10 this time, all right? And so let's start with question 1. If x minus 1 over 3 equals k and k equals 3, what is the value of x? For this one, this is just basic algebra. So we're going to start with substitution. Everywhere you see a k, you're going to put a 3. So x minus 1 over 3 equals 3. Now we can write 3 as a fraction by putting it over 1. Now here we can sit there and cross multiply, or sometimes I like to call it the butterfly method. So x minus 1 times 1, anything times 1 is itself, so x minus 1. 3 times 3 is going to give you 9. And then we're going to go ahead and add the 1 to both sides. So we're going to get x equals 10. And that is our answer. So D is going to be our answer for number 1. Okay. Let's go on to practice question number 2. For I equals -1, square root of -1, what is the sum 7 plus 3i plus -8 plus 9i? These right here are complex numbers. The form of a complex number is a plus bi, where a is our constant and bi is our complex number. So for this, it's kind of like combining like terms. So first we're going to add our constants together. So 7 minus 8. And then we'll add our complex numbers together. So plus 3i plus 9i. 9i. 7 minus 8, that's going to give me -1. 3i plus 9i, that's just like combining our like terms. So that's just going to give me 12i. So our answer for this one is going to be A. This one we didn't really have to use the I equals square root of -1. Let's go on to question 3. This one is a word problem. With word problems, I always think it's important to annotate. So on Saturday afternoon, Armando sent M text messages each hour for 5 hours. And Tyrone spent P text messages each hour for 4 hours. And they're asking us which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon. So first thing, we have to set up 2 equations. I'll let A equal Armand. And this is going to be like multiplication for 5 hours. He sent M text messages. And then for Tyrone, for 4 hours, he sent P messages. And I need to add both these together. Now, adding both of these together, I can't really combine them because they're not like terms. One has an M, one has a P. So that's the farthest I can simplify them down. So our answer will be C for 3. Okay, let's move on to 4. Another word problem, and again, we're going to annotate. Kathy is a repair technician for a phone company. Each week, she receives a batch of phones that need repair. The number of phones that she has left to fix at the end of the day can be estimated with the equation P equals 108 minus 23D, where P is the number of phones and D is the number of days she has worked that week. And our question right here, what they're asking us, what is the meaning of the value 108 in this equation? Now notice that this equation is kind of set up like a linear equation where we have y equals mx plus b. And m is our slope. And remember, slope always deals with rate. And then b is our just constant, right? And this equation right here, 108 is our constant. And usually when we have a constant for our linear equations, it's going to sit there and represent our starting point, okay? Or when my x is 0. So if we look through these and read through these, Kathy will complete the repair within 108 days. It's not talking about, the 108 is not representing like what she'll finish in that time, all right? And then it says D is the number of days. So 108 is not really dealing with that. So A is not a possibility. Kathy starts each week with 108 phones to fix. Look at this keyword starts, all right? Like I said, our B is our constant, and usually with linear equations, our y-intercept is going to represent where we start. So that might be a possibility. But always, when doing your SAT, go through all your questions and always eliminate the ones you know are wrong. Kathy repairs phones at a rate of 108 per hour. This rate, whenever you see like a rate or something like that, or per, it's mostly talking about our slope. Right here, we're not talking about our slope. We're talking about our y-intercept. So it's not going to be C or D because those have rates, and we're not worried about rates. We're worried about the starting point right here. So the answer is going to be B. All right. So let's go on to the next one, number 5. Which of the following is equivalent? Remember, equivalent in math means the same to the expression above. So right here, we're just using algebra to simplify. First thing, notice that we have a negative outside of our parentheses. So we want to distribute that negative to each and every term in our second term right there. So let me just rewrite the first term right here. Oops. Sorry. So let's rewrite the first term right here. That just comes along for the right, x squared, y minus 3y squared plus 5xy. Nothing changes there. Only thing that's going to change is my second one terms, because I'm distributing that negative through. Negative times a negative is positive. So then I have plus x squared y minus 3xy. Oops, sorry, that's crazy looking x. Y squared. And again, negative times negative is a positive, so plus 3y squared. So now after sitting there distributing that through, now I just want to combine my like terms, right? X squared, y squared. I have another x squared, y squared here, and we're going to combine their coefficients. So the coefficients of those being combined, the coefficients of this one is 1. The coefficients for this one is -3. Oh, my apologies, not that one. My bad. It's going to be, this one has like terms, right? X squared, y, x squared, y. Coefficient for both of these is 1, so I add their coefficients together. 1 plus 1 is 2. Now I have x squared, y. Now my second pair of like terms, I have this y squared right here. So I look for my other coefficient with the y squared, which is right here. -3 plus 3, that's going to cancel out. So that just goes away. And then my last like terms are these ones right here, my xy squared and xy squared. So I have 5 minus 3, that's going to give me plus 2 xy squared. So our answer for this one is going to be C. And I know I might be going a little fast. If you have questions, put a comment below, but I want to try to get through all 10 of these problems on this video. Next one is number 6, another word problem. A pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age a in years. Between the ages 2 and 5, based on the model, what is the estimate increase? So they're telling us the height is going to be increasing. And the boys are in inches of a boy's height each year. Okay. So that's what they want to know. Notice they said that A is age. So we're going to sit there and find out the height for each of these ages, 2 through 5, and find a pattern in what we find in our heights. So first, let's start with 2. So everywhere I see a I'm going to put a 2. So 3 times 2 plus 28.6. And I just want to sit there and find the height for this one. And so we have 3 times 2, that's going to be 6. And then we have 6 plus 28.6. Or my apologies. Yeah, 6 plus 28.6. So it's going to give me 34.6. Now let's find the height for boys of age 3. Okay. Remember, I'm just trying to find a pattern for what my outcomes are. So 3 times 3 plus 28.6. Okay. That's actually going to give me 9 plus 28.6. All right, and then 9 plus 28.6, that's going to give me 37.6. That's another outcome. Like, let's find the age of one more. Let's do age 4 to sit there and see if we can find a pattern. So 3 times 4 plus 28.6. Oops, that's crazy looking 6, but that's okay. That's actually going to give us 40.6. 40.6. So now I want to sit there and see the differences in all of my outcomes. In math, when you want to sit there and see how something changes or the differences between something, you subtract them. Okay. So if I do 37.6 minus 34.6, I'm actually increasing by 3 to get to that height. Now let's see if we can find a pattern. If I do 40.6 minus 37.6, again, it's going to be 3. I'm pretty sure if I find the height of a 5-year-old, I'm going to get the difference between that outcome and 40.6 to be 3. So we can safely say that the estimated increase is 3 inches for each age. Right. So let's go on to the next one. Now let's do number 7. This one looks like it's mostly going to be Algebra 1. So the formula above gives the monthly payment M needed to pay off a loan of P dollars at R% annual interest over N months. Which of the following gives P in terms of M, R, and N? So we just want to isolate P to be all by itself. So I don't think we have to do a lot with this stuff in the middle. Let's just try to sit there and see how we can isolate P. First thing I notice, if I sit there and multiply both sides by the reciprocal, I can sit there and get P to the other side. So multiply both sides by 1 over P. I did this because this way my P's cancel out. And now I'm stuck with M over P equals, and I'll just put like whatever's in these parentheses. Now I can also multiply one sides by 1 over M. So I can sit there and get rid of the M because remember, I want my P to be all by itself. So multiply both sides by 1 over M. Right. Those M's cancel out. Now I'm going to have 1 over P equals all this on top of here, under all this bottom here, times 1 over M. Now, if I want to sit there and bring this P up, that's kind of like the inverse, right? Doing the inverse of P. So I'm doing the inverse of all this. So let me take it up here. I'm running out of room. Sorry. I'll have P equals whatever is on the top. I think they will switch because I'm doing, nope. Yeah, they'll switch because I'm doing the inverse. So whatever goes up top goes up here. Inverse, it switches. So as you see right here, what I mean by it's switching, because we're doing the inverse. My 1 plus 1 over r goes on top. And then whatever's down here goes on the bottom. I just switched it because it's an inverse. And my m is going to be multiplied by all of it. So our answer is going to be B. And on this one, on SAT, I wouldn't sit there and try to write out every single little thing because we're just trying to isolate P. We successfully did that by sitting there doing these algebraic steps. Okay. Now let's do 8. If A over B equals 2, what is the value of 4B over A? So first, we need to find the value of this, but first let's isolate either our A or B so we can plug it into this expression. I think it's going to be easier to sit there and solve for A first because all we have to do is multiply B by both sides. So if I multiply B by this side and then multiply B by this side too, my B's cancel out right here. I get A equals 2B. Now that I have my A isolated, I can go ahead and substitute it into here. So everywhere I see an A, I'm going to put a 2B using substitution. My B's are going to cancel out. 2 goes into 4 twice. So my answer for this one's going to be 2, which is C. Okay. Let's keep on going. Let's go to 9. What is the solution XY to the system of equations above? I'm going to add a video with the section of based on systems of equations, just in case you need to freshen up on them because they will pop up on the SAT. For this one, I'm going to sit there and use the process of elimination. You could use substitution if you'd like, but for this one, I'll tackle it with elimination. So with elimination, we just want to sit there and manipulate one of our equations, either our first or second equation, and try to cancel out a variable by adding the two equations together. In this case, I'm going to sit there and manipulate the bottom equation, right? Let me just line everything up, and I'll show you how I'm going to do that manipulation. Lining up my x's, lining up my y's, and lining up my constants. Equals negative 19. So I'm going to sit there and try to eliminate my x variable because if I just multiply this whole second equation by 3, I'll get a negative 3 and I can cancel my x's out. All right, so let's go ahead and do that. Let me just go ahead and write down my first equation for y equals negative 23. Now that 3 is going to distribute to each and every term in my second equation. So then I get negative 3x plus 6y equals negative, I believe that's negative 57. Yes. Okay. Then what I'm going to do is I'm going to add these two equations, and then we'll see my x's cancel out. And then I'm left with 10y equals negative 80. Divide both sides by y, you get y equals 8. My apologies, negative 8. Now, if I was taking an SAT test and I was sure that I was correct on that one, I wouldn't sit there and plug in the negative 8 into one of these. Well, if I had time on my test, I would plug it into one of my equations and then sit there and make sure I get the same x variable. But I'm pretty sure because none of my other options have a negative 8 that I'm correct. All right. So then let's do our last one, which is 10. And for this one, the function g defined above, a is a constant and g of 4 equals 8. What is the value of g of negative 4? For this one, our first step is we want to find that a, all right, our constant. And we can do that because g of x is equal to 8 when my 4, or when my x is equal to 4. So everywhere I see an x, because this represents my x, what's getting plugged into my function, right? So then I have 4 squared plus 24. Right. Then I'm going to have 16a because 4 squared is 16. Then I'm going to go ahead and subtract that 24 from both sides. When I subtract that 24 from both sides, I get negative 16 equals 16a. I divide both sides by that 16 so I can isolate my a. I'm going to get a is equal to negative 1. Now that I got what my constant is, I can go ahead and plug in the function for x equals negative 4 and substitute in my negative a that I found, or my negative 1 that I found. So g of negative 4 equals, everywhere I see a, I'm going to put a negative 1. For this function, everywhere I see a x, I'm going to put a negative 4 squared plus 24. All right. And then I keep on working down. So negative 1, negative 4 times negative 4, because negative 4 is squared, is 16. And then plus 24. So then that means we have negative 16 plus 24. Oops. Plus 24. Which is going to give me positive 8. So 8 is going to be our answer here. Okay. All right. And so again, these problems are from College Board, practice test 1, no calculator portion. If you have any questions on any of the answers that I got or how I worked out any of these problems, please leave a comment in the comment section down below. And if you have any SAT or homework questions you would like to ask me, just put in the comment and I can reply back showing step by step what the answer is and how I got to that answer. Thank you guys.